Hey, seventh graders, we're going to get going with helping you finish up this speed and acceleration lab that we did rolling a marble down a ramp. I'm going to help you finish up labeling your data table and also help you calculate acceleration. All right, so here we go. All right. What I did is I cut one of your guys' data onto the screen here. Now I know some of this is hard to make out, so I'm going to go over it a little bit. But a couple key things when you copy this data table back into your lab. Remember that we are going to add acceleration to this. So make sure when you hand in your lab report that, and don't do it like this, make sure you use a straight edge, but we're going to add acceleration. All right. Again, this is somewhat difficult to calculate, so I'm just going to walk you through it so that you guys understand how to do it, and I'll show you in class, but you can use this video if you need some help. All right, so this group has found the average time that it took the marble to travel these distances. All right, biggest thing you need to make sure when you rewrite this lab that you put seconds here. Remember, label your column headings always. Speed, the proper unit for speed is meters per second in this case. Meters per second, m/SEC. All right, meters per second. Now acceleration is what we're going to be looking for. Now I have the paper copy in front of me. This should be a 135. This is going to be a 1.42 because I know it's hard to make out. I'm just going to rewrite it. 1.26, 1.17, 1.19, and 1.26. Now right away, before you start calculating acceleration, we need to remember that not only is this speed, but we can also refer to this as velocity. Remember, velocity is speed in a given direction. All right. So when I show you the formula for acceleration, I'm going to use the word velocity. All right. Now, getting into this, all right, before we calculate acceleration, all right, we have to recognize what's taking place. So I have 1.35 meters per second. All right, is the rate at which the marble was traveling, all right, one distance. Now, we look at the distance, the speed it took the marble to travel 2 meters, we have 1.42 meters per second. Well, this is a greater number. So what does that tell us? Well, it tells us that the marble is going to accelerate here. The marble actually picked up speed, all right, on its way to 2 meters. Now we have 1.26. This is a smaller number than 1.42. So 1.26 meters per second shows us that the marble is starting to decelerate. Again, 1.17. It shows us that the marble is decelerating across the floor. And then 1.19 and 1.26 meters per second, it appears that the marble is starting to accelerate again. In fact, it's the same speed at 6 meters as it was at 3 meters. So this is kind of some interesting data. So since acceleration, by definition, is the change in velocity, we can actually see that there's going to be some numbers that are going to be positive because the speed is increasing, and there's also going to be some situations here where the number is going to be negative simply because it's slowing down, and we're going to talk about that as we calculate these. All right. So those are some key things to think about. Now, acceleration. Okay, is found by, all right, final velocity minus original velocity over time. Now notice I abbreviated these. The V2 represents final velocity minus original velocity over time. Okay? This is our formula that we're going to use. Now we're going to have to, this is a formula that's going to involve multiple steps. You have to think of your orders of operation. We're going to do the top first, then we're going to do the bottom, then we're going to divide, and then that should give us the results. All right. So we're going to not do 0 to 1 meters because we don't have the time at 0 meters. So we're going to have to first calculate the acceleration at 2 meters. Okay? So the final velocity at 2 meters, all right, is 1.42. All right, I'll put the units. Minus. All right, we're going to go back, all right, to its original velocity at 1 meter, which was 1.35 meters per second. Over. Now this is a little bit tricky. The time, all right, that it took the marble to travel, all right, 1 to 2 meters, we're going to actually have to take and subtract, this is looking at the sheet of paper that I have here, this 1.41, all right, and this is less than a second, 0.74. So now what I'm going to have to do is I'm going to have to subtract these two to figure out how much time passed in between meter 1 and meter 2. So now I have 1.41 minus 0.74. Okay? All right, this is how we're going to set this up. Notice that this is 2 meters and 1 meter, and this is 2 meters and 1 meter. All right, so the next one that you do would be 3 meters and 2 meters, and so on and so on. All right, so let's do a little math. I'm just going to have my calculator off to the side here. Just going to do a little math to figure this out. All right, so I'm going to enter in 1.42 minus 1.35, which equals, all right, so now I'm going to move down here, rewrite the problem. So now I have 0.07 meters per second. That is the change in speed. All right, that's the change in speed over how much time went by when that was taking place. We're going to take a look at 1.41 minus 0.74 equals 0.67 seconds. All right, now I'm going to simply take 0.07 divided by 0.67 equals. All right, I have an answer of 0.1, and the decimal is 0.104477. That's what you'll see on the calculator if you do this yourself. So I'm going to round to the nearest hundredth, as we've talked about, and that's exactly what this is. This is round to the nearest tenth, all right, but my hundredth place is a 0, so this is where I'm going to leave it. And now this is the crazy unit, meters per second per second. We're going to talk a little bit more about what this means in class, but this means that every second that goes by, this marble is increasing by 0.1 meters per second every second that goes by. And this is our acceleration for 2 meters. The marble has, as you can see, we looked at how it increased speed. Well, how much did it increase speed by? 0.1 meters per second per second. Now, I don't want you to put this here. This is going to be our column heading here. We're not going to put the unit every time. So let's erase that just so we don't get confused. All right. Acceleration is going to be in units of meters per second. It can also be written squared. Oh, let me erase this one more time here. Running out of space. Meters per second squared. We'll talk about this more in class as well, but meters per second squared is another way to write meters per second because there's 2 seconds for your units. Okay? So that is how you find acceleration. Not easy, and we're going to do some examples on the board, but you can reference this video to remind you how to do this. And again, that's how you find acceleration. Now remember, we are looking here. This next one, you're going to have to use some math skills because now we are decelerating. We're slowing down. So you can anticipate this number being negative. And that's okay, because that's exactly what should be happening. We're experiencing negative acceleration, which we refer to as deceleration. Okay, 7th graders, some challenging stuff, but I know you can do it. All right.